an independent editorial defense analysis focused on Australia's strategic environment.
The fundamental contradiction of modern maritime patrol lies in the platform itself. For decades, the tactical imperative of anti-submarine warfare dictated that aircraft must descend to skimming altitude. They had to expose the airframe to salt spray, turbulence, and immense structural fatigue, all to deliver a weapon with a footprint barely larger than the aircraft itself. The transition of the Royal Australian Air Force to the P-8A Poseidon, a militarized derivative of the Boeing 737, exacerbated this tension. Utilizing an airframe designed for high-altitude commercial transit for low-level tactical maneuvering presents a distinct operational inefficiency. The integration of the high-altitude anti-submarine warfare weapon capability, or HAAWC, therefore represents more than a mere munitions upgrade. It signals a structural realignment in how the Australian Defence Force manages high-value aerial assets. It shifts the P-8A from a frontline tactical brawler to a standoff command node. This evolution is underscored by the recent industrial integration of Australian suppliers into the HAAWC supply chain. The announcement that Ferra Engineering will manufacture wing and tail kits for the system indicates that the guided weapons and explosive ordnance enterprise is moving beyond simple acquisition toward component-level participation. However, from a capabilities perspective, the significance of HAAWC is that it decouples the sensor platform from the weapon release point. Conventionally, a P-8A detecting a submerged contact would be forced to break its surveillance orbit. It would have to descend from 30,000 feet to a few hundred feet, and it would expend significant fuel and time to execute an attack. This maneuver not only stresses the airframe but creates a tactical delay, a window of minutes during which a sophisticated adversary might evade detection or deploy countermeasures. By attaching a GPS-guided wing kit to the standard Mark 54 lightweight torpedo, the system allows the munition to be released from cruising altitude. This gliding torpedo can travel significant distances, reportedly up to tens of kilometers, before jettisoning its wings and entering the water to begin its acoustic search. Operationally, this allows the P-8A to remain at its optimal fuel efficiency altitude. It drastically extends its time on station. For a nation like Australia, tasked with monitoring vast maritime approaches across the Indian and Pacific Oceans, the ability to maintain a persistent patrol without sacrificing fuel for attack acts as a force multiplier. It effectively increases the patrol radius and loiter time of the fleet without the need to procure additional airframes. Survivability constitutes another critical dimension of this upgrade. The proliferation of submarine-launched anti-aircraft missiles and the increasing lethality of surface combatants accompanying submarine task groups have made low-altitude flight paths perilous. P-8A conducting a traditional torpedo run presents a large, non-stealthy radar cross-section. Keeping the aircraft at altitude and at a standoff distance aligns with a broader trend in Western air power doctrine, one which prioritizes keeping high-value intelligence, surveillance, and reconnaissance platforms outside the lethal envelope of enemy air defense systems. The HAAWC integration suggests an acknowledgement that the permissive environments of the past 2 decades are disappearing. They are being replaced by contested zones, where asset preservation is paramount. However, this capability introduces complex dependencies on network architecture. The separation of the launch platform from the target area by tens of kilometers introduces a time-of-flight variable that does not exist in traditional gravity drops. During the minutes the weapon is gliding, the target submarine may maneuver. Consequently, the efficacy of the system relies heavily on the ability to transmit mid-course updates to the weapon. This requires a robust and jamming-resistant data link. This highlights a vulnerability in the kill chain. If the electromagnetic spectrum is degraded or denied by electronic warfare, the advantage of standoff range may be negated by the inability to accurately guide the weapon to the target's predicted position. Furthermore, the reliance on the Mark 54 torpedo as the warhead imposes its own set of constraints. While the delivery method is revolutionary, the terminal effect remains bound by the limitations of a lightweight torpedo designed primarily for an era of different threats. There remains an open analytical question regarding the lethality of such munitions against modern double-hulled nuclear submarines capable of deep diving and high speeds. The acquisition of HAAWC improves the delivery mechanism, but does not inherently solve the problem of terminal effectiveness. It suggests a doctrine of suppression and disruption, forcing an adversary to evade rather than guaranteeing a catastrophic kill. The industrial aspect of this program also reflects a nuanced shift in sovereignty. While manufacturing components domestically through companies like Ferra Engineering fulfills political mandates for Australian industry content, the intellectual property and the complex guidance systems remain firmly within the United States control ecosystem. This deepens the interoperability between the Royal Australian Air Force and the United States Navy. It ensures that logistics and ammunition stocks are interchangeable in a crisis. Yet, it also cements a dependency on American technical data and software updates. The ability of Australia to independently sustain this capability without external support is limited. This reinforces the reality that Australian sovereignty in high-end guided weapons is often exercised within the boundaries of alliance architecture. Financial implications also present a trade-off that defense planners must weigh. The addition of a guidance kit turns a standard torpedo into a significantly more expensive round. This cost differential may influence rules of engagement and training regimens. In a high-intensity conflict, the expenditure rate of high-cost precision munitions often outpaces production capacity. While the bunkers at Orchard Hills are being expanded to accommodate such inventories. The stockpile depth of these specialized kits versus standard torpedoes will determine the sustainability of air-dropped anti-submarine operations in a prolonged campaign. Ultimately, the HAAWC program illustrates the transition of the Australian Defence Force toward an asymmetric, technology-centric posture. It prioritizes the preservation of platforms and the extension of reach over the sheer mass of forces. While this aligns with the demographic and economic realities of Australia, it places an immense burden on the reliability of sensors and data networks. The P-8A is evolving from a hunter-killer into a high-altitude manager of the battle space, directing kinetic effects from a distance. This shift enhances the strategic utility of the airframe, but inextricably links the success of anti-submarine warfare to the resilience of the digital networks that connect the aircraft, the weapon, and the wider theater command. The effectiveness of this system will depend not just on the aerodynamics of the wing kit, but on whether the networked kill chain can survive the friction of modern electronic combat.